Hi everyone, this is Mrs. GA, and today we're going to review how to graph quadratic functions. Before we start, I have a quick warm-up for you guys, so please pause the video and give these three a try, and go ahead and hit play when you're ready to check your answers. Alright, so go ahead and check your answers. So here I did say you could use the method of your choice, so maybe the method used is different than mine, but your answer should be the same. So for part 1, I chose to factor this, so you can factor out a GCF of 5x, and you get another factor of x plus 3, and then you do zero product property for these two answers. For part B, I also chose to factor this. Since it's a trinomial and your a value is 1, you can use that magic x. So here are your factors. Then you can do zero product property from there. For part C, you can actually factor this one. You can use difference of two squares, but just for a different method, I chose to do the square root method. So you can isolate x squared and then take the plus or minus square root of both sides. So I prefer this method whenever there's an x squared term but no x term. And then notice here when I do the plus or minus square root, you take the square root of the numerator and denominator. So square root of 4 is 2 and the square root of 9 is 3. And don't forget about that plus or minus sign. So today we're going to take a step back from solving quadratics, and we're going to look at how to graph them. So here's the parent function for our quadratic function family. It's f of x equals x squared. So all quadratic functions will make a parabola shape. The parent function here has a vertex at 0, 0. So this is our vertex. That's going to be a really key point when we're graphing. And it's usually going to be kind of our starting place when we're graphing. Now, I also want to talk about a few other things that can apply to our quadratic function. So first, there is a vertical growth pattern that all quadratic functions follow, and we can use this pattern to help us graph a little bit more quickly, and we can generalize it for different types of or different equations. So I want us to look at a few points that we know for sure. So we have 0, 0, 1, 1, 2, 4, and then 3, 9. So those are points that we know are our whole numbers. So if you look at the vertical change from each one, for between the first 2 points, I go up 1 over 1. So from here to here, my growth is 1. And then from to the next point, we go up 3 over 1. So from here to here, we're increasing 3. And then from here to our next point, we actually go up 5 over 1. And you could probably guess that to find our next point, we would go up 7 over 1 and then up 9 over 1. So you can see that the vertical growth is increasing by 2 each time. So we can kind of use this pattern, and again, we can adapt it for different equations, but I like to say that the vertical growth pattern is 1, 3, 5. And then we are going to, when necessary, multiply that growth pattern by your a value, which is sometimes the coefficient of x squared. So let's say our a value was 2. Instead of having a growth pattern of 1, 3, 5, it would have, you multiply it, so it would have a growth pattern of 2, 6, 10. So again, you can apply this same growth pattern of 1, 3, 5, 7, 9, so on and so forth, and you can adjust it for any a value, and it helps you find the next point. So once you have the vertex, you can just use your growth pattern to graph the rest of your function. So the next thing I want to talk about is whether a graph has a maximum or a minimum. So we'll have one or the other. So the maximum or minimum, first of all, will always occur at the vertex, no matter what. Now, the way you determine if you have a maximum or minimum is simply by looking at your a value. So if you have an a value that is positive or greater than 0, and again, a would be any coefficient of x squared, you end up with a positive graph. I like to say that it looks like a smiley face, like a happy face, because it is positive. And anytime you have that, that's going to create a minimum. You can see that our graph clearly reaches a low point, but it's going to go up forever, so it only has a minimum value. Now, anytime your a value is less than 0, you end up with a sad face graph. So a negative a value kind of gives you a sad graph like this. So you can see here that these types of graphs have a maximum. So to tell if you have a minimum or maximum, it will depend on whether you have a positive a value or a negative a value. When you're graphing, another really key point that we'll be finding today is the y-intercept. So the y-intercept is, we can find it by setting x equal to 0. And we're always going to make sure to write our y-intercept as a coordinate, so it'll be 0 and then a value. And then the last thing we'll be finding today is what's called the axis of symmetry. So the axis of symmetry is kind of the imaginary line over which your graph is symmetrical. So you can see actually if you draw a vertical line right through the center of your parabola, imagine you folded your paper on this line, your graph would match up. So it's symmetrical about this line, and that's called the axis of symmetry. So the axis of symmetry is, for these types of parabolas, is always going to be a vertical line. So it's going to be x equals, that's how you make a vertical line equation, and it's always going to go through the x value of your vertex. The axis of symmetry always goes right through the middle. So it's always going to be x equals the x value of your vertex. So that's how we'll describe this line. So in this case, our axis of symmetry would be x equals 0, which is the x value of our vertex. Okay, so today we're going to review how to graph quadratic equations from 3 different forms. So again, these forms just depend on how you're given the equation. So the first form is called standard form, and it looks like this. It's ax squared plus bx plus c. So to graph this, we do need a little formula. You need to memorize this formula to help you find the vertex. So this is going to be really important. So you start by finding the x value of your vertex using the formula negative b over 2a. So again, that gives you the x value, and then all you have to do is substitute it into your function to find the y value of your vertex. So once you have the vertex, you can use the a value to help you with your vertical growth pattern, and then the rest should be easy from there. Now, this next form is called vertex form, and it looks like this. So it's a times x minus h squared plus k. So we call this vertex form because it's really easy just to look at the equation and tell what the vertex is. So the vertex is always going to be hk. So notice h is the number that's grouped with x, and k is the number that's outside of x. So one thing to notice is you'll see here that this says minus h and this has a positive h. So these are always going to be opposite. So it's really important to note these are opposites, and then these stay exactly the same. But again, you can really easily find the vertex when it's in this form, and then you still have that same a value, which you can use to adapt your vertical growth pattern to plot your remaining points. The last form is called intercept form, or it's sometimes called factored form, and it looks like this. So it's f of x equals a times x minus p times x minus q. So p and q are just two values. So you can see that it is factored out, just like we've been learning to do. And so the numbers inside of your factors, the opposite of those numbers are going to be your zeros. So if you have a negative p here, positive p would be your 0 or your x-intercept. And if you have negative q, this is positive q. So again, when it's in this form, all you can really tell by looking at it is what your x-intercepts are. So your zeros, again, 0 is kind of synonymous with x-intercepts. And then I'll show you when we do this example how we can use those to find your vertex and graph the rest of your graph. All right, so we're going to start by graphing two equations that are in standard form. So for example 1, we have f of x equals x squared minus 8x plus 9. So the first thing we're going to need to do is find the vertex, and we're going to use that formula x equals negative b over 2a. So that's going to help us find the x value of our vertex. So here we can see that b is negative 8 and a is 1. So let's substitute that. So negative 8. Notice there's a negative built into the formula, and then that other negative comes from the function, divided by 2 times 1. So the x value of your vertex, so this becomes positive 8 divided by 2, which is 4. So we need the y value in order for us to find the full vertex. So next we're going to find what f of 4 is. And that simply involves us substituting into the function. So f of 4 is going to be 16 minus 36 plus 9. So this gives us f of 4 equals negative 5. So our vertex is 4, negative 5. So that's going to be our starting point when we graph. So let's start with that. So we have 4, negative 5, which is right about here. Okay, so to help us find our remaining values, we can use that 1, 3, 5 growth pattern. So you'll notice in this case that our a value is 1, so that means that our growth pattern stays just 1, 3, 5. We don't need to adjust it for a stretch or a shrink. So the way we use it, again, we start at our vertex, we go up 1 over 1. It's always going to be over 1. And then from that point, now we're starting here, we go up 3 over 1. And then from that point, we go up 5 over 1. And then we can simply reflect those points onto the other side of our graph. So up 1 over 1, up 3 over 1, up 5 over 1. And then we can connect them to make our parabola. So you can see since our a value is positive, we have that smiley face graph. Anytime we have that smiley face graph, it is going to result in a minimum. Okay, so our minimum, because we do reach a low point. And we can see what that minimum value is. So the minimum value would just be the y value that's the lowest. So it's negative 1, 2, 3, 4, 5. So it's always going to be the y value of your vertex. So the minimum occurs at y equals negative 5. Now let's find the y-intercept. So remember, we find the y-intercept by setting x equal to 0. So we're actually going to find f of 0. So we're going to substitute 0 wherever we see x. So 0 squared minus 8 times 0 plus 9. So f of 0 is just 9. So you're going to notice a pattern whenever it's in standard form. Our y-intercept is always going to be that c value. So our y-intercept is at 0, 9. And then the last thing we need to do is we need to find a way to describe this axis of symmetry, which remember is this vertical line that goes right through the center of your graph. So since it is a vertical line, we use the equation x equals, that's how you write a vertical line, and it's always going to be the x value of your vertex. So x equals 4. And there you have it. So now we have all of the main features of this graph, and we have our nice graph over here to the right. All right, let's try another one together. So here we have f of x equals negative 2x squared plus 8x. So let's start by finding the x value of vertex. So we have to use that same formula. X equals negative b, which in this case is positive 8, divided by 2 times a. And a in this case is negative 2. So this gives us negative 8 divided by negative 4, which is positive 2. So that's the x value of our vertex. So now we need to find the y value of our vertex. So we're going to substitute it into our function. When you're simplifying this, be careful. We always need to make sure we do our exponent first. So here, in the correct order, we do 2 squared, which is 4, and then we multiply it by negative 2. So then it becomes negative 8. So f of 2 is positive 8, which means our vertex is 2, 8. So let's start by graphing that point. So 2, 8 is right here. Okay, so now let's assess what our growth pattern would be. So in this case, you can see that we do have an a value, and this a value is negative 2. So to find our growth, we actually do negative 2, and we're going to adjust that 135 growth by multiplying negative 2 to all of the values. So the growth is actually negative 2, negative 6, negative 10. So from the vertex, since it's negative 2, we're actually going to go down 2 over 1. Then we go down 6 over 1. And then we can even go down 10 over 1. And then we can simply reflect this onto the other side of our graph. Just like this. Okay, now since our a value is negative, you can see that we ended up with that sad-faced graph. And anytime we have this type of parabola, we are going to have a maximum, because you can see our graph hits a high point. So this one is a maximum, and it occurs when y equals 8. Okay, the y-intercept, we can actually see from this graph that our y-intercept is at the origin at 0, 0. Remember, another way of looking at it is seeing what that c value is, which is also 0, or by substituting x equals 0 into our equation. So just to show you guys, our y-intercept always occurs when f is 0, or when x is 0. So this is 0, this is 0, f of 0 equals 0. So it confirms that our y-intercept is at the origin. And last, we want to describe this axis of symmetry. So vertical line makes x equals, and it's always going to be the x value of vertex. So x equals 2, and there you have it. Okay, so now let's move on to graphing from vertex form. So I actually think that graphing from vertex form is much quicker and easier because, again, we can see what the vertex is just by looking at our equation. So remember, our vertex is always going to be hk. We have to make sure to do the opposite of this, and then this stays the same. So our vertex is actually negative 4, 6. So let's start by plotting that point. So here is our vertex. Now, to find our next points, let's look at our growth pattern. Here you can see that our a value is negative 1. It's always going to be that number out front. So we actually need to do negative 1 times that 135 growth pattern. So it's negative 1, negative 3, negative 5. So from our vertex, we go down 1 over 1, down 3 over 1, and then down 5 over 1. and then simply reflect it onto the other side. And then just connect your dots to make your parabola. Okay, so here, since our a value is negative, we get that downward facing graph, and we do have a maximum. You can see it occurs right here, and that's going to occur at the vertex, the y value of a vertex. So our maximum is at y equals 6. Our y-intercept, again, we can find it by substituting x with 0. So here we can't just rely on this number because this is not in standard form. So we do need to plug it in. So we have to do f of 0. So we have negative 0 plus 4 squared plus 6. So here, 4 squared is 16. So this becomes negative 16 plus 6. So f of 0 equals negative 10. So our y-intercept is at 0, negative 10. So if you kind of continued on our graph, you can see that it would hit right there at 0, negative 10. And last, our axis of symmetry is the vertical line that goes straight through our vertex. So we say x equals, and it's always the x value of your vertex. Okay, let's try one more of these together. So here we have f of x equals 1/2 times x minus 3 squared, and then there's nothing here. If it helps, maybe for you to visualize, we can write in a plus 0, because then you could see that our h and k values are still really there. So we have 3, 0. So sometimes k is 0, like you see here, or sometimes h is 0, and either way is totally fine. So let's start by plotting that vertex, just like this. And for our growth, so we do have an a value of 1/2. So it's going to be 1/2, and we have to adjust that 135 growth. So it's 1/2, 3/2, 5/2. So here you're going to kind of need to estimate a little bit. I'm going to zoom in. So from your vertex, we go up 1/2 over 1. You still go over 1. So we have a point here and a point here. And then we go up 3/2, so here, and then over 1. And then we go up 5/2, so 1, 2, 3, 4, 5 over 1. And then connect your dots to make your parabola. Okay, so since we have a positive a value, we have a positive smiley face graph, which always comes with a minimum value. It has a bottom, so a minimum. And in this case, our minimum is at y equals 0. Let's find our y-intercept. So remember, we always find the y-intercept by setting x equal to 0. So 1/2 times 0 minus 3 squared. So be careful here, 0 minus 3 is negative 3, but when we square it, it becomes positive 9. So we have positive 9 divided by 2, which is just simply 9 over 2. So our y-intercept is at 0, 9 over 2, which is right here. 9 over 2 is 4.5. So you can see that our graph matches what our y-intercept should be. And then last, here's our axis of symmetry. Vertical lines are always x equals, and then it's always the x value of your vertex. So x equals 3. All right, so now we're going to graph from our last remaining form from that intercept form. So here we have f of x equals negative x plus 4 times x minus 2. So here you can see that we have two intercepts. We have two x-intercepts, or two zeros. So the first x-intercept is at negative 4. Remember, it's always going to be the opposite of this value. So it's at negative 4, 0. And then this x-intercept is at positive 2. So our zeros are negative 4 and 2. So we can actually plot those 2 points to start. So once you know where your 2 x-intercepts are, the vertex is always going to be exactly in the middle of those 2 intercepts. So it might be above, it might be below, but the x value will always be exactly between negative 4 and positive 2. So we know that the exact middle of negative 4 and positive 2 is at negative 1. So I'll make a little mark here. This is not our vertex, but we know it's going to be somewhere on this vertical line. So if we know that the vertex occurs when x is negative 1, all we need to do is plug that in to our function. So we need to find f of negative 1. So we have negative, and then negative 1 plus 4, and negative 1 minus 2. So this gives us negative times 3 times negative 3. Remember to always simplify inside your parentheses first. And then this gives us positive 9. So our vertex is negative 1, 9, which we could plot right here. And then if we want to be more accurate, so we already have 3 points, we can find more by using that growth pattern. So here you can see that our a value is negative 1, so we know that our growth 1, 3, 5 needs to be multiplied by negative 1. So it's negative 1, negative 3, negative 5. So down 1 over 1, down 3 over 1, right here, and then down 5 over 1 brings you to your x-intercepts. There we go. So for this one, since it is a downward facing graph, due to that negative a value, we do have a maximum, and our maximum occurs at y equals 9, the y value of your vertex. Now we need to find the y-intercept. We can find the y-intercept by setting x equal to 0. So we need to find f of 0. So negative 0 plus 4 times 0 minus 2. So we have negative 4 times negative 2. So f of 0 equals 8. So 0, 8, which confirms exactly what we see on our graph. Our y-intercept is at 0, 8. Last, we need to describe our axis of symmetry, which is this vertical line. So it's just going to be x equals negative 1. Always going to be the x value of your vertex. All right, so here is our last example. We have another graph in intercept form. So we have 2 times x minus 3 times x plus 1. So we can see our zeros are 3 and negative 1. Remember, it's always the opposite. So to write those as intercepts, it'd be 3, 0, notice positive 3, and then negative 1, 0. So those are our x-intercepts. And remember, our vertex is always going to occur exactly in the middle of these two. So the exact middle between negative 1 and 3 is at positive 1. So it's actually going to be somewhere on this line. And to find it, we just need to find what f of positive 1 is. So we're going to substitute it into our equation. So we have 2 times negative 2 times positive 2, which is negative 8. So our vertex is at 1, negative 8. So down here. Here we can adjust our growth pattern. Notice that we have that a value of 2. So instead of a 1, 3, 5 growth, we get a 2, 6, 10 growth. So again, from our vertex, we go up 2 over 1, and then up 6 over 1 gives us our intercept, and we can even go up 10 over 1 if it ends up fitting on our graph to get a more accurate parabola. There you go. So notice positive a values give us happy face graphs, which have a low point. So this graph has a minimum at y equals -8. The y-intercept we can see is at 0, -6, but just to confirm, let's find what f of 0 is algebraically. So substitute 0 into your equation. So 2 times -3 times +1 is -6. And last, we need to find a way to describe this vertical line, the axis of symmetry. So it's always x equals, and then we take the x value of your vertex. All right, so that's been our review of graphing quadratic functions. That's it for the video. Thank you so much for watching. So now we're going to take a step back from graphing, and we're going to kind of do the opposite. So we're going to actually be creating the quadratic function. So here we're asked to create the quadratic equation that has a vertex at 4, 2 and goes through the point 8, 18. So I think for these types of problems, the best thing to use is that vertex form. So we have this equation to start with. So y equals a times x minus h squared plus k. So from the given information, we know a couple things. We are told that the vertex is 4, 2. So if the vertex is 4, 2, that means that our h value is 4 and our k value is 2. So we're going to substitute those in. And notice it does say x minus h. So it will say x minus 4. And then we're also given this extra point. So anytime you're given a point on any graph, this is simply an x and y value that go together. So they're telling us that when x equals 8, y equals 18. So we know to make an equation for a quadratic function, we need to know 3 things. We need to figure out what a, h, and k are. So luckily we know 2 of the things already, but we don't know that a value. So we do need to substitute everything we know so we can find our a value. So in place of y, we're going to put 18 equals a, which we don't know, times, and then in place of x, we're going to put 8, and then we have minus 4 squared plus 2, and this will allow us to solve for a. So we just need to make sure to follow our order of operations here. So here we have a times, remember to subtract, and then we're going to square. So 8 minus 4 is 4, 4 squared is 16, plus 2. And then we can subtract 2 from each side, so 16 equals 16a, and then divide by 16 on each side. So a equals 1. So now we know a is 1, we know h is 4, and we know k is 2, so we can make our function. And maybe this time instead of saying y, I'll say f of x equals 1, so we don't need to write it, times x minus 4 squared plus 2. All right, let's try another one together. So this time we are told that we have a vertex at 0, 1. So again, that tells us h is 0, and k is -1. And we're also told that this graph goes through the point -1, -3. So we know that when x is -1, y is -3. So we'll start with our vertex form. And again, we need to know a, h, and k to make our function, and we still need to find a because we know what h and k are from the given. So let's substitute everything we know. Y will be -3 equals a times x is -1 minus 0 squared plus negative 1. So we'll say minus 1. And now all we need to do is solve for a. So here, negative 1 squared is positive 1. So it's just going to be 1a minus 1. And then we add 1 to each side. So a equals negative 2. So now we know our a value, so we can make our entire function. So it's negative 2 times x. Now be careful here. We're going to do x minus 0. So we actually don't need to write anything. X squared and then minus 1. And that's our function. So the last thing we're going to do today is learn how to rewrite an equation that's in standard form in vertex form, because some people prefer to do this to graph because graphing from vertex form is much quicker and easier. So our goal is to make this, again, look like this. Here's our goal. That a times x minus h squared plus k. So our distinguishing feature in vertex form is this binomial square, this x minus h squared. So to do this, we do need to complete the square. So we're going to use kind of that same process for completing the squares when we learned how to use it for solving, but we're going to apply it a little bit differently. So here, the first thing we need to do is we need to move this constant to the other side of the equation. So we're going to subtract 9 from each side. And I'm going to replace f of x with y. So we have y minus 9 equals x squared minus 4x. Now, the reason we did this is because we need a perfect square trinomial right here. So now we're going to use that completing the square formula. Hopefully you guys remember that for completing the square, we do that formula, which is b over 2 squared. And that gives us the magic number that will complete our square. So to find our magic number here, our b value is negative 4. So we do negative 4, we divide it by 2, and then we square it. So that actually gives us positive 4 because negative 2 squared is positive 4. So we're going to add 4 to each side. This gives us y minus 5 equals x squared minus 4x plus 4. So our next step is now to factor because we want this to look like this. So we can factor using magic x, and we want two numbers that multiply to make 4 and add to make negative 4. When we're completing the square, it should always be the same number twice. So it's a binomial squared. We're going to write it like this. X minus 2 squared instead of writing it out twice. So you can see that now this looks very similar to this. We have our x minus h squared. All you have to do is move this value to the other side. So we're going to add 5 on each side, and we get y equals x minus 2 squared plus 5. And if you'd like, you can even write it back with the function notation. And now we have something that's going to be a lot easier for us to graph. We can see that the vertex is at 2, 5. All right, so here's the last example for the entire video. So here we're going to be rewriting again in that vertex form. So our first step is going to be the same. We need to take this number and we need to move it to the other side. So we're going to do y minus 71 equals 3x squared plus 30x. Now, before we complete the square and find our magic number, there's a really important rule for completing the square, and that rule is that your a value must be 1. So here, since I have something other than 1, we need to see if we can actually factor it out so it's separate. So you'll see that these two terms have a GCF of 3. So we can actually divide out the 3 and write it like this. X squared plus 10x. Now we have space to complete our square inside the parentheses. So we're going to use our little formula. Here's our b value. So remember, for completing the square, it's b divided by 2 and then squared. So we have 10 divided by 2, which is 5. Then we square it and we get 25. So that's what we're going to add right here. Now we do need to add it to the other side, but here's the tricky step. It looks like we're adding 25, but really this 25 is being multiplied by the 3. So while it looks like we're adding 25, we're actually adding 3 times 25, which is 75. So that's what we need to be adding on both sides. So you can see I added 75 on the left. And this gives us y plus 4 equals 3 times x squared plus 10x plus 25. And now this we need to factor. So again, we can use magic x, but it should always be a binomial squared. So what two numbers multiply to make 25 and add to make 10? 5 and 5. So we can write this as 3 times x plus 5 squared. And then our last step is to isolate y, so we need to subtract 4 from each side. And then I'm also going to rewrite this back in function notation. So 3 times x plus 5 squared minus 4. So now you can see it's in vertex form. Our vertex is at -5, -4, and it has that vertical stretch by a factor of 3. All right, that's all for today's video. Thank you guys for watching.